Hello everyone, and thank you for joining with us for this call. And I'm Mahendrini Ariyachandra. I'm working as assistant professor at UCL, and joining me today is Dr. Yaven, a postdoctoral researcher from University of Cambridge. So today's talk will focus on a project that we are working on, which is dedicated to advancing ecosystem urbanism by automating the creation of digital twins for sustainable cities. So this project is a collaboration between University of Cambridge and 13 other partners across Europe and UK. So this project aims to develop innovative applications that enhance buildings' energy efficiency and improve clients' resilience and sustainability. So we are utilizing cutting-edge technologies such as satellite data analysis, digital twins, virtual and augmented reality, and drones equipped with thermal cameras. So the services provided by this project will enable users to interact with buildings' digital twin, which allows city stakeholders to monitor energy performance effectively. So this will ultimately help in developing strategies to enhance cities' sustainability and resilience against climate changes, focusing particularly on urban thermal environments and flood risk. So in today's session, we'll discuss the technology bit, which is behind these innovations, especially how we generate digital twins of buildings at the city scale using automated methods. So moving on to the digital twin generation part, I'm going to talk about the main elements in here. So as the input, we are using a static data set that includes registered point cloud data, including visuals and thermal data. So the expected output is the object-oriented model of building objects and ultimately the model of the building at the city scale, featuring tessellation, type, axis geometry, and their spatial relationships. So the question here is, how does this output, the digital twin, enhance sustainability practices? So the high fidelity multimodal digital twins that we generate at a city scale will provide decision support services for various sustainability goals. So they will be used as the basic platform to map, to analyze, and to visualize the parameters related to energy demand prediction, urban heat, and urban flood analysis. For example, the parameters related to the energy labels, real-time energy consumption, and the age and the size of the buildings will be mapped on these models, and the models will then be used to visualize and to create live maps of building energy profiles, which allows us to evaluate building's energy performance comprehensively. So now I would like to invite Dr. Wen to discuss the digital twin generation process in more detail.
Thank you, Dr. Ariyachandra. Here, I would like to show the technical pipeline of the BuildSpace project. The work starts from the data collection. The existing building asset in the project's pilot are scanned from either drone images, terrestrial laser scanning, or airborne laser scanning. The point cloud data is segmented, detected, and classified through the deep learning or computer vision method. After the semantic segmentation, the FC element is generated with also the spatial relationship information. This relationship embed is valuable for the further use of the digital twin. Through this comprehensive process, the constructed result is shown in the XR environment with the real-world geolocation information. Next slide, please. So until today, we have completed the overall development of the building envelope. In this process, we still find that there are some challenges that we need to face in the practical scan to digital twin process. The first one is in each project, actually we have various focus points depending on the different objectives of the pilot teams. Each pilot has different scenario and backgrounds to scan their building asset. For this method, we need to develop an integrated method to complete the digital creation job, regardless of the point cloud data collection method used. The second challenge is that the current scan-to-digital twin practical process mostly relying on the data-driven method. However, the knowledge of the building is not efficiently utilized. Our research is still going on, and these challenges leads us to the further research. So, yeah. In this slide, we show the one of our further direction, the scan to graph. To accurately present the spatial relationship of digital twin is always the key value of the scan to digital twin process for the further dynamic digital twin understanding. But it is also a challenging topic because of the complex data structure in the building industry, such as the IFC standard. In the further work, our team will focus on the novel method to embed the spatial relationship information into the constructed digital twin instead of manually input it. So here shows the scan to graph, like the map. Scan to graph is the key direction of us, and this information is generated from the knowledge to improve the completeness of the digital twin. And here is our publication presented in the conference in this year, describe this work. In this paper, the value of graph generated in the scanning process is also discussed. It can be integrated with the building domain knowledge for the further information query, such as the energy analysis or the facility management perspective. So in the next slide shows our the other direction, and this is to show the integration of the large language model into the digital twin creation process. Large language model can also be used to understand the indoor or outdoor scene, so we can predict the complex typologies within the building only based on the XYZ coordination and also the semantic label of each point. Moreover, in the next step, when the input includes the spatial relationship of the building elements, the large language model can facilitate the IFC file generation based on the current IFC library, such as the IFC OpenShell, and this can enhance the accuracy or effectiveness of the digital twin modeling process. So here's our presentation, and we are happy here to answer some questions. Thank you.
Next question to our two doctors, please, is the paper referenced available for us to read?
Yes, it is. So we can share the link through the chat, so everyone can read the paper and understand the process in more detail. Yeah.
So back to our two doctors, please. Thanks for the presentation. To what extent did you use the standardized digital twin terms when developing your system?
I'm going to answer that question. Actually, it depends on what you call standardized in here. So what if you read the paper, we have defined what we call the digital twin in our terms. So we try to link it to the well-established definitions and frameworks such as Digital Twin Consortium, where their standards and how they have defined the digital twin. So we have used the standardized terms that we mentioned on our paper, so that the output that we are creating is aligned with the industry best practices. Yes. So there are more details on the paper. You can read through that. Yeah.
Very good. And then I'm going to go to a link question here. Is the data you used for creating a digital twin in the public domain?
Yeah, I can answer this question. In this project, actually, our data to generate the digital twin is for sure is collected by the project team. And this is the real, I don't think it's public, but it should be private to the project team. But the training data we use actually from the public database. And also we use some our own collected data to do the training. For example, the facade detection of the windows, openings, doors. Actually, we collect our own data of different building facade, and we use this data set to train the computer vision network and to identify the different category of the building.